Magandang araw mga kaininyerong sibil. Ako ang inyong guro, Darrell J. Mendros Balbin. In this video, I will solve the fourth sample problem in pipe connections and reservoirs. Three reservoirs A, B, and C are connected by a pipe system. Find the discharge into or from each of the reservoirs. Use F equal to 0.02 for all pipes. For pipe A, the length is 1,200 meters and the diameter is 300 millimeters. For pipe B, the length is 600 meters and the diameter is 250 millimeters. And for pipe C, the length is 800 meters and the diameter is 200 millimeters. Let us assume that the junction where the flow will be divided is located at point B. This will make the flow at point B equal to 0 for the meantime. What we're going to do is determine the discharge when this is head loss A and the discharge when this is head loss C. So head loss A is equal to 100 meters minus 70 meters, and that is equal to 30 meters. Since we were given frictional factor F in the problem, to solve for HA, we will be using Darcy-Weisbach formula. That is equal to 0.0826 FL1 Q1 squared over D1 raised to 5. Substituting the values, F as given in the problem is equal to 0.02, L1 is 1,200 meters, Q1 is unknown, D1 is 0.3 meter, and this is equal to 30 meters. Solving for Q1, Q1 is equal to 0.192 cubic meter per second. Next, head loss C is equal to 70 meters minus 50 meters. That is equal to 20 meters. Once again, using Darcy-Weisbach formula, it is equal to 0.0826 FL3 Q3 squared over D3 raised to 5. Substituting the values, F is 0.02, L3 is 800 meters, Q3 is unknown, D3 is 0.2 meter, and this is equal to 20 meters. Solving for Q3, Q3 is equal to 0.0696 cubic meter per second. This means that the flow under the first pipe, Q1, is larger than the flow on the third pipe, Q3. To balance this, due to the conservation of mass, Q2 will be receiving the excess flow from Q1, which now means that Q1 is equal to Q2 plus Q3. This would also mean that the head of the junction point with respect to the energy grade line is below 100 meters and above 70 meters since water flows out of A and flows into B. This is now HA, HB, and HC. We can now get the relationship of the heads of each pipe with respect to the head of the junction point. The first relationship is HA plus HB is equal to 100 meters minus 70 meters, and that is equal to 30 meters. Using Darcy-Weisbach formula, for HA we have 0.0826, F is 0.02, L1 is 1,200 meters, Q1 is unknown, D1 is 0.3 meter, plus for HB we have 0.0826, F is 0.02, L2 is 600 meters, Q2 is unknown, D2 is 0.25 meter, and this is all equal to 30 meters. Simplifying, we have 815.8 Q1 squared plus 1014.99 Q2 squared is equal to 30. This is our equation 1. Using equation 1, it will be useful to express Q1 in terms of Q2. That is, Q1 is equal to the square root of 30 minus 1014.99 Q2 squared all over 815.8. For the next relationship of heads, we have HC minus HB is equal to 70 meters minus 50 meters. And that is equal to 20 meters. Using, once again, the Darcy-Weisbach formula, we have for HC 0.0826, F is 0.02, L3 is 800 meters, Q3 is unknown, D3 is 0.2 meter. Minus, for HB we have 0.0826, L2 is 600 meters, Q2 is unknown, D2 is 0.25 meter, and this is all equal to 20 meters. Simplifying, we have 4,130 Q3 squared minus 1,014.99 Q2 squared is equal to 20 meters. And this is our equation 2. Again, it will be useful to express Q3 in terms of Q2. That is, Q3 is equal to the square root of 20 plus 1014.99 Q2 squared all over 4,130. We have 3 unknowns, namely Q1, Q2, and Q3. So far, we have 2 equations. Now, we need one more equation to solve these 3 unknowns. Where will we get that equation? Actually, we already have the third equation, and that is Q1 is equal to Q2 plus Q3. Remember? So what we're going to do is substitute in equation 3 Q1 in terms of Q2 and Q3 in terms of Q2. So this will be the result. You can see that in this equation there is only one unknown, and that is Q2. Therefore, we can solve for Q2, and Q2 is equal to 0.0852 cubic meter per second. Now that we know Q2, we can easily solve for the flow rate of the other pipelines. To solve for Q1, we simply use the equation of Q1 in terms of Q2 and substitute the value of Q2. Therefore, Q1 is equal to 0.167 cubic meter per second. And finally, to solve for Q3, we simply use the equation of Q3 in terms of Q2 and substitute the value of Q2. Therefore, Q3 is equal to 0.0814 cubic meter per second.